Hey, what's going on, guys? Makefile here. Last video we have finally implemented our parseFen function. So starting from this one, it's already time to think about how to move our pieces along the board, and in order to achieve that sort of a goal, we need to define the piece move offsets, and I will deeply explain, well, at least I'll try to explain what exactly the piece offsets are and how to define them. But before that, I just want to add one little more file to this project, and this would be a Makefile. So if I just call this file like Makefile, if memory serves me correctly, it shouldn't be literally enough just to call this Makefile like this, and here I just need to say all and switch to tabs instead of spaces, and here just to say GCC and our chess hexadecimal 88.c minus O chess hexadecimal 88. Okay, yeah, this is kind of it. So I really hope it should kind of work, because I'm already tired to print this compiling command every time, and from now on, if you just open the terminal in the current working directory and simply type make, it should have compiled. Yeah, perfect. So if I say make, and if it makes just to run this chess hexadecimal 88, it would also yeah, just chess. Oh, it's slightly bit wrong name within the Makefile, so hold on a sec. 0 here. Okay, now this should work. Okay, perfect. So yeah, this is kind of it. Now just get rid of this executable, because we don't really need this, and we don't need Makefile as well. Okay, so let me just try to show you one little thing. I'm sorry for having my business email being open here. So just where to go? Let's go to Lichess. So if we have a look at our analysis board, so as far as we do represent our chessboard as the array of integers, basically, the only reasonable way of defining of kind of what the move is actually to specify the offset that we either subtract or add, or subtract from the current given square. So let's consider we have this E2 square. So if we want to add this to move this pawn one square ahead, how do we calculate the destination square index? So we have the target square index right over in here, right? We can actually now I guess we can print this. So I'm just wondering how exactly yeah, I guess I can use my squares. So let's try this little trick here. So printf, and I want to print this decimal number, and let's say square E2. It should now give me the offset. Okay, we got this 100. Perfect. So okay, and let's say we want to print the target square kind of E4, or first let's try E3. So you see, like 84, and if we subtract 100, subtract 84 from the 100, we'll get exactly 16, and this 16 is the exact offset that we need to take care of in order to calculate the target square. And say we want to ask the index of the square of E7, okay, and 20, and now if we just want to ask the index of square E5. It would be 36 because 20 plus offset of I'm sorry, this was plus 32, so if not divided by 6, this should be 36. Okay, and again, if we just make it kind of plus 16 and plus 16 again, so just double move, in that case obviously that would be 52. So this is the idea that lies under the entire logic of specifying the move generators for chess engines, and but first we would be implementing the e-square attack function using the piece move offsets in order to answer the simple question whether the given square is attacked by the piece of a given site. But in order to implement that sort of a function, we need to make some sort of a preparation, which is the topic of this video in particular. So I suggest to start implementing our move offsets, and then we'll go to some preparation regarding printing the map of printing the attacked squares map. So let's go to the very top of our source file, and somewhere over in here, let's define our piece move offsets. Okay, and these guys would be arrays. So let's say pawn offsets, and there would be, so well, I'll first just try to implement them, and then I'll count how many there would be. So this regards, well, probably, well, I don't know, probably we can even drop pawns for now, because both the move generator and the e-square attack function doesn't really involve this pawn offsets. There are some interesting implementations where they do occur, but I think, yeah, so probably we will better start with knight offsets. So pawn offsets would have been involved, but they would have been involved like just on the fly. So and I'm gonna be referencing them via this erase. So let's start from the knight offsets, which is the most complicated offsets, I must say. So let's try to calculate them. So let's consider I just want to print this to screen to make it a little bit more clear. So I will now manually reset my board to make it kind of empty. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, should be empty now. Okay, and somewhere in the center I want to kind of skip 3 squares, put a white knight there, and then skip 4 squares. So here we got our knight, which is quite pretty nice, standing in the center, right? And now let's try to generate the moves for this knight. So we have this knight standing on d5. So let's print d5, d5, save, and the square index for d5 is 51. And now let's kind of see, like humans, where exactly knight is about to come. So here, here, then here, 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 and here, right? So let's now try to print all this sort of squares, and that's the reason how we calculate the offsets. So let me grab this line and paste. So the very first square to print would be C7. Well, maybe even well, no, let's start with the C7. Okay, so let's print C7, and then let's print this one E7. Okay, E7, and then let's print well, let's consider this one. So b6, b6, and then consider like f6. So the half of the moves of the offsets would be positive, and the rest of them would be negative respectively. So let's consider b4 here. So b4, and now f4, and it will be way easier to deal with bishops, rooks, queens, and kings. So just okay, f4, and now c3 and e3, yeah. So f4, c3 and f3 here. Save, and let's just print this, guys. So now in order to calculate this offset, so first let me just try to print this right over in here. So let me get my super calculator, and let's go. So we have our 51, which is the initial one, so minus 18. Okay, and this would be 33. So the first of the offset 33. Okay, the next one. Oh my god! So I need this terminal. I need the calculator. Okay, now 51 minus 20. Okay, and this would be 31. Okay, so the next thing is 51 minus and 33. Okay, so this is gonna be 18. Okay, and now 31, oh sorry, 51 minus 37. Okay, we got 14. Okay, perfect. And the rest of the offsets should be negative numbers. But let me just try to quickly check that, and I'll get back to you in a moment. Well, okay, so it seems to be quite pretty reasonable offsets. So let's get back to our knight move offsets definition here. Where are they? Okay, and then we specify minus 33 and minus 31 and minus 18 and minus 14 as well. So this is kind of the order doesn't really matter that much. So we got 8 elements here. Okay, so 8 integers within this array. So the next thing to consider would be to have bishop offsets. So bishop offsets, and this would be 4 offsets. So for bishop it's quite pretty trivial. So we got this plus 16, it's not going there, so it's either going to 15 or 17, right? So the bishop offsets would be 15, 17, minus 15, and minus 17. 15, 17, minus 15, and minus 17. Okay, and the same offsets are for the pawns to actually to capture another piece. Now int rook moves, rook offsets, and this would be 4 as well here. So with the rook we can move upwards, downwards, so plus 16, minus 16, plus 1, and minus 1 to the left and to the right. So quite pretty trivial. So 16, minus 16, and 1, and minus 1. And now for what else do we have there? So we need the king offsets and the queen offsets, but the queen offsets are combined from, so they are literally the same. So just hold on a sec, I just want to think how it would be better to implement this stuff. Yeah, I guess the key in attacks would be literally enough here, so key in offsets, so key in offsets also 4 here, and keen can combine both the bishop and the rook offsets. So let's give him this guys and also this as well. So this is how the king is gonna move here. Okay, let's try to compile and run this stuff to make sure it still works. Okay, sorry. Print word, did I miss? Yeah, I just missed the semicolons. He doesn't forgive you missing the semicolons. Did I miss something else? Whoa, just really wondering like what's gonna run here. Inc, not ink, but int, integer. Inc, that's a little bit different story. Yeah, integer. Okay, so does it work? Yeah, no warnings now, perfect. So, or hold on a sec, we still have some warnings. Oh, so just the hold on guys, so here we have 8 elements, right? So yeah, now it doesn't give any warnings anymore, so just needed to specify the appropriate number of elements within the given array. Well, so this is already pretty nice, and again, like as I've been already mentioning, it would be a reference in the pawns on the fly. So now let's get rid of this stuff. We don't need this really, and I want to implement one little function at the end of this video, and this would be called something like print attacked squares, and I just want to make use of this. Well, I can actually grab my print board up to here, right? Okay, and going back, and I just want to call this print, let's call this attack, print attacked squares. And probably we need to int site to define which to attack by, but what kind of site these squares are about are attacked basically. Okay, so print in ranks is just fine. Here we don't really want to print this stuff. We'll drop this for a while. And just wondering. So I didn't yet. So well, I just wanted to start working on the square attack function in the next video, but I will now just draft square attacked. It would be the type of integer is square attacked function, and just to show you one little trick here. So if we return 1, this means that the square is attacked, and here we will be printing, so printf, and we would be printing a character like this, I guess. Yeah, like this. And now we want to ask, so is square attacked, and the square attack would be taken in square attribute followed by the int site to move. So we can say is square attacked and pass in the current given square, and the site would be forwarded from this site that is passed to the print attacked squares. And here Oh my god, I forgot how this syntax called, like triple oh my god, I forgot how this is called basically. Hold on guys, just want to Google that. Okay guys, this is called ternary expression. So this sort of stuff, we've been using this within our many places basically. Like here, this is the ternary expression, so they're about within the print board function as well. So ternary expression, or ternary operator, probably it's called so as well. So in case if the square is attacked, we want to print this x, and otherwise we want to print the dot. So x for the attacked square and the dot for the non-attacked square basically. And the very last thing left here before we end this video, I just want to call this function called print attacked squares, copy. And let's say we're asking if it is attacked by the white pieces. Okay, so now in theory it should give all the x's, because the e square attack returns a true or 1 or true all of the time. Okay, probably missed some semicolon or something. Is square attacked square. Oh, let's read what's wrong here. Expected declaration of statement. Print attack squares in function print attack squares. Hold on a second, just it's kind of wrong. Do you really want this to be enclosed within the parentheses, but it doesn't have to be the point. Oh my god, I have no idea like what's going wrong here. So at least tell me what the line there is. So 320 and 1 300. Oh yeah, this is a bit strange to be honest. Print attack squares. Okay guys, just hold on, I need to debug this stuff. Okay guys, it seems like I forgot to enclose the function with this curly braces. It should work now. Okay, perfect. And yeah, and also I can print this also I can print out my files. Okay, so and file, right? No, sorry. So oh my god, what am I doing? I need just to say like A, B, C, D, E, F, G, H. Okay, and so just to prettify this slide a little bit. And a couple more. Like it's always really handy to create this cute pretty printed things here, like printing the board, the attack maps. It's always pleasant to see, to look at them and to work with them. This is incredibly handy and really nice and good looking. This makes me feel happy when I see this like stuff. And one little more trick. So in case if we're returning say 0, in this case we'll have like all the dots, which means that no square is attacked, well, by the white pieces, but now it doesn't really matter that much like what kind of side is attacking. So starting from the next video, we're supposed to be implementing the actual logic of asking the question whether the current given square passed to the e-square attack function is actually attacked by a given piece or not. So until the next video, hope to see you there as well. So this is it from my side. So take care guys.